Hey guys, welcome to another video, and today we'll be looking at atomic energy, right? So atomic energy is the energy being released from the nucleus of atoms. This can be because they join together or the atom splits to get smaller ones, right? So that's what the atomic energy is, right? And the energy released was actually calculated by using the equation E equals delta m c squared, where delta m is your mass defect, c is your speed of light, which is 3 times 10 to the 8 meters per second squared, right? Meters per second, sorry. The mass defect is the change in the mass from the parent atom to the daughter atoms. So on the left side of the equation, minus the right side of the equation, right? Now an atom will actually split because it is unstable. Unstable meaning that the number of neutrons and protons in the nucleus is not equal. So once that number is not balanced between neutrons and protons, then the atom is described as being unstable, and that unstable feature will cause the atom to split or decay. Alright, so one type of getting nuclear energy is nuclear fusion. So nuclear fusion, as the name suggests, is combining two small ones to get a larger atom, right? So in this case, we have two isotopes of hydrogen, which combines to give us helium, right? And it releases energy. So this reaction actually is a primary reaction that happens on the sun. So that's why the sun is actually a primary source of helium gas, because this type of reaction happens regularly, right? And then for nuclear fission, this is where large atoms, they split now, right? So we have a larger atom and it splits into smaller atoms to release energy, right? So those smaller atoms now are more stable atoms, right? So these decay of atoms, they continue until they get an atom that is actually stable, right? So it's a continuous process until it attains a stability in terms of neutrons and protons in the nucleus being equal, right? So we're going to look now at an equation for the nuclear fission. Alright guys, so this here shows us a reaction for the nuclear fission, right? So we have a high-speed neutron that's allowed to hit the atom, the unstable atom, that causes it to split. So the uranium atom is collided with a neutron, which splits it into molybdenum and tin, right? And it gives us neutron and the energy that we need. Now, if we add our top numbers, we get 236, because 235 plus 1 give us 236. So the top numbers here, so this and this is 234, but this we only have one neutron here, so that means we put 2 here, so we can add 2 to it to get the 236 that is here. And then the bottom numbers, 92 plus 0 is 92, 42 plus 50 plus 2 times 0, which is 0, we get back 52, right? So all atomic numbers, all mass numbers should be equal, both on left and right, right? Now we look at the chain reaction, because scientists use this to actually get our nuclear energy, primarily in our nuclear plants, right? So the energy that is being released from one atom of uranium or any unstable atom is not enough to actually work for what we want it for. So we use a chain reaction, because here we notice that we have two neutrons that's becoming free, right? So if we just have one uranium here, which we ask the neutron to collide with it, it splits it into molybdenum and tin, right? Then it releases two new neutrons that can actually, if we have more uranium, can actually collide with those to give us, to actually break away, right? So we have different stages where uranium is, and once these are split, we get energy, right? So areas where the uranium splits, we get energy being released. So now we can add up those energy to give us a final energy. All right, thanks guys, and that's the end of today's lesson. See you next time.